Hello everyone. Now we are at the third part of the practice questions, and this is maybe a little bit difficult for you to understand because this is not the kind of house that you see in Singapore nowadays, and even in a modern house today, it's usually a flat rooftop, and many of us rely on air conditioning to keep our house cool. So such designs may not be evident in Singapore context. But nonetheless, let's go through the questions. Now, what we have here is you're given that this kind of design is found in tropical regions. So what do you mean by tropical regions? So intuitively, you're supposed to have the word hot environment at the back of your head. Now, receive a higher concentration of radiation emitted from the sun and are thus hotter than most regions on Earth. The buildings in countries found in these tropical regions are often designed to keep the occupants cool. So you see, keep cool, right? Keep the occupants cool. So figure 10.25 shows a type of house that can be found in some parts of the tropical regions. A material known as Attap is used to cover the rooftop of such houses. Now note, at the beginning of the question, you are given that it receives a higher concentration of radiation emitted from the sun. Okay, so here it gives you the idea that it may have given you the idea that radiation plays a big part here. But what it's trying to tell you is that the rooftop is heated by radiation, which could have led to problems in part 1. Now note that in part 1, the question asks, 4 different materials are arranged in order of increasing thermal conductivity as shown below. Thermal conductivity. So the first thing that comes to your mind has to be conductor of heat. Thermal conductivity. Based on the given information, explain the use of Attap as a rooftop material. It helps to keep the inside of the house cool. So we are asking, I'm going to zoom in, and how does this design help to keep the house cool? When you look at this Attap has a layer of thickness. Now, if it is a poor heat conductor, okay, what can I say about the heat transfer from one end to the other end? So note, this side here gets heated by radiation from the sun, and here, the inside, heat is conducted through the Attap from outside the house to inside the house, as shown by the arrow that I've drawn there, right? By this arrow I've drawn here. Okay, heat is conducted from the outside to the inside, and that's exactly what this question is asking for, which many of you couldn't really understand what they're asking for. Okay, so being a poor conductor, it reduces the rate of conduction through the roof from the outside to the inside. And for some of you, you loosely interchange the terms conduction and radiation. So you can tell me that heat is conducted through the atom from the outside to the inside of the house, right? And then you start talking about absorbing the heat. So these are completely two different things, and you have really gotten conduction and conduction and radiation totally confused. Next, part 2. The type of house shown in figure 10.25 often uses a high ceiling which traps air. So what they are asking for is this region. This region traps air, right? So what idea do you get from here? Intuitively, air trapped, right? How is air related to heat transfer? Now, you know you're trying to keep the house cool. And when you try to keep the house cool, you're trying to reduce the rate of heat transfer into the house. And air is a poor conductor of heat. So whatever heat that has gotten through the Attap in your part 1 has now to face a layer of trapped air, which reduce the rate of heat conducted through the trapped air to the inside of the room. So in this way, it helps to keep the room cool for a longer time. Now, another group of students actually felt that the space is filled with warm air. Alright? You stated that warm air rises and remains there, so the cool air can come into the house. Right? Ask yourself, as long as the warm air doesn't leave the house, how is the cool air going to come in? That itself is not logical. Right? So the air becomes stagnant. House cannot be cool. Another group wrote that the warm air continues to rise to the high ceiling. Now, does that sound logical? The warm air continues to rise? Right? This space is finite. Okay, it's going to reach a point of time where it cannot accommodate any more warm air. So how can this logic hold true? What I'm trying to illustrate here, this is one way you can reflect on your own answer. And it definitely will contradict your thought process. Because air cannot keep accumulating at one point, right? Once you contradict your thought process, stop, erase everything, start to deeper thinking. Next, this design. I think most of you should be familiar with this design. It's actually in Singapore right now. It's actually in Jewel. We have an enclosed glass building, different kinds of plants in there, right? It's at the Jewel top floor, okay, where the cooling pipe runs, with running water flowing through it, okay. You ask yourself, why is it cooling, right? The hot air escapes from the top and the cool air flows in from the side. And most of you are distracted by this glass building, right? If you look at it carefully, it's kind of a bit of a distraction because the glass building doesn't really play a part in the idea of physics here. The glass building merely lets sunlight through so that the plants can photosynthesis. So it doesn't really play a part in any cooling mechanism here, and quite a large number of you walked right into it. So this question requires you to think through a little longer, right? Shouldn't really dive into it, okay? As I mentioned, the unique part of this question are the running water in the pipes and the hot air escaping the top. If you can understand how these 2 points work, you more or less have already answered every question within here. Now, the running water in the pipe serves to carry the heat outside the building, from the inside to the outside, and the heat that naturally has to come from the visitors and the plants. For part 2, the process by which hot air is removed by the glass building is known as convection. This one I can't really teach you because you have to see the flow of air first, then you can deduce that it's convection. And in part 3, okay, Right. Now, as the warm air rises out through the opening, something must come in to fill the space. So it has to be the cooler air from the outside. Okay, once the hotter air rises up, the space has to be filled in by the cool air coming from the side door, right? And the only way for this cool air to be heated is from the people and the plants. And they get heated when they come in contact with the visitors and plants, and it becomes less dense, it rises out from the opening in the building. So this whole process will continue, and this will ensure a cool air continuously flowing in to the building.